The blob of mashed carrots in this problem is launched straight up at a speed of 9.5 meters per second. It goes up towards the ceiling. We're asked to find the speed that it splatters on the ceiling with, and we're told that the ceiling is a distance 3.60 meters above the child's plate. Let's call this height y equals 0. We know that while the carrots are in flight, their acceleration is constant. It's minus g in the negative y direction, so minus 9.80 meters per second squared. Part A asks us to find the speed of the carrots just before they hit the ceiling. It's easiest to do this using the time-independent kinematic equation. The square of the final velocity equals the square of the initial velocity plus twice the acceleration times the displacement. The acceleration is minus g. We can substitute the known numbers. The displacement is 3.60 meters, change in position from launch till hitting the ceiling. When you calculate and take the square root, you find the carrots hit the ceiling moving at 4.44 meters per second. Part B asks us to find the time that passes between launch and hitting the ceiling. There are several ways to do this. Perhaps the easiest is to use the time-dependent velocity equation, which tells us that the final velocity equals the initial plus acceleration times time. Acceleration is minus g. We can solve this equation for the time. It equals the difference in the velocities, final minus initial, divided by the acceleration, minus g. Substitute the numbers and calculate. To find the time of flight is 0.516 seconds.